Okay, let's say that I was given the arc length S and I was given the angle theta that we pass through of 73 degrees, and I want to find the area of that piece of pie. Well, the formula for area is 1/2 theta times the radius squared. They didn't give me the radius. They gave me theta and S. So what am I going to do? I'm going to take the formula S equals theta times the radius, and I'm going to solve that for r by dividing both sides by theta. So what we're going to do first in order to find the radius is to take the arc length in this picture of 0.3651 feet and divide that by theta, but theta's got to be in radians. Oh my. So I'm going to come on over here. I guess I'm going to do it right over here. And I'm going to take that 73.61 degrees and I'm going to multiply that by pi over 180 degrees. The degree symbols cancel out when I do that. And I get a value for theta of 1.285 radians. So I'm going to come on over here and divide this by 1.285. Remember, a radian is a unitless measure, so you're taking something in feet and dividing it by something without any units. And when you do that, you get 0.284 is the length of the radius of this sector. So now I'm going to come on over here in this formula and I'm going to take half of theta. Remember, theta is 1.285, and I'm going to multiply it by the radius, which I just found to be 0.284 feet squared. And when I do that, I get my final answer. The area of this sector, remember the length in feet was very little. It was just inches long. And so the area is 0.052 square feet. A little bit more challenging because I gave you S and theta and you had to find R. Same is true for the next one. In the next one, let's go ahead and take the 17 degrees first. And let's get it in terms of radians. Let's multiply that by pi over 180 degrees. So that turns out to be 0.3. All right. They gave us A and they want us to find S. And so to find S, we have theta, but we need R, and we don't have it. So I'm going to come on way over here, and I'm going to take the formula A equals 1/2 theta times r squared, and I'm going to solve this formula for r. I'm going to get r alone because I got to put it in over here. So I'm going to go ahead and multiply both sides of this equation by the number 2. What that does for me is it gets rid of the 1/2 on the right-hand side. So now what I have is 2 times A on the left and theta times r squared on the right. So now I'm trying to get r alone, so I'm going to divide both sides by theta. And that gives me, so these cancel out right here, that gives me 2a divided by theta equals the radius squared. Well, I want to know what the radius is, so now I got to take the square root of both sides in order to get the radius. So the radius is going to be found by taking the square root of twice the area divided by theta. And so I'm going to go ahead and calculate that now. So 2 times the area of 1200 millimeters. I'm just putting the units under it so that you can see that when you take the square root of it, you're going to get an answer in millimeters. Divided by theta, which is 0.3. You know, I can see in my notes that I used 0.2967. So I just want you to know that when I get this answer of 89.94, it might not match yours exactly. Because I didn't use 0.3, I used 0.2967. But now I'm going to come on up over here. Finally, I'm going to find the arc length by taking the value for theta, which is 0.3 radians, times the radius of 89.94 millimeters. And when I do that, I get an answer for the arc length of, there it is, 26.6 millimeters. Okay, very good. The next one's a little bit more practical. Nothing has been so far, to be honest. But I've even talked to my friends who work for General Motors, and they've done this with windshield wiper blades, have had to do this. This could even be done with putting grass seed down in a circular sector. So a spotlight beam sweeps through a horizontal angle of 75 degrees. So I'm going to try to show a spotlight. This is my spotlight right here. And it shoots out its light, and it sweeps back and forth and back and forth through a 75-degree angle. The range of the spotlight is 250 feet. That's how far out it can go. So I want to know the area that it can cover, and the formula for area is 1/2 theta times the radius squared. Well, again, you got to take that 75 degrees. Please, this is what you're going to forget to do possibly, and multiply it by pi over 180 degrees, and that's 1.309. So I'm going to take half of that 1.309, which is in feet. Oh, I'm sorry, that's an angle. That's unitless. I was thinking about the radius. And I'm going to multiply it by the radius of 250, that's in feet, squared. And when we do that, I get 40,906 square feet. Don't forget, if you use my math lab, it's probably going to round that answer off to 41,000 or something like that. Okay, a section of sidewalk is a circular sector of radius 3 feet with a central angle of 50.6 degrees. What's the area of that sidewalk? Same kind of problem. So say you came up to, here's a sidewalk, moving along, and then all of a sudden it had to turn a little bit like this. And somebody was getting ready to pour the concrete in order to make the sidewalk go on like this. And they were pouring this section right here. This angle is 50.6 degrees, and the radius is 3. So if I take the theta of 50.6 degrees and I multiply that by pi over 180 degrees, I get 0.883. Then I'm going to find the area of that section by taking half of that 0.883 and multiplying that by 3 feet to the second power. And that value is going to be almost 4 square feet, 3.97. But, truthfully, if I was pouring this concrete with a hand mixer, I could then multiply it by a depth of 4 inches, which would be about 4/12 of a foot. I'm kind of curious now. So if I multiplied that by 4 divided by 12, this is just for the fun of it, I'd need 1.3 cubic feet of concrete to pour that little section. Okay, let's, I think we have time to go ahead and do the next one. This one's pretty fun, I think. The latitude of Miami is 26 degrees north. And the latitude of the north end of the Panama Canal is 9 degrees north. Both are on the same lines of longitude. So I'm going to go ahead and, you know what? I actually think this is getting to be a 9-minute segment. I'm going to do these next 2 story problems in a new segment. So now we've read this one. Let's get ready to think about it. Would you look up lines of latitude and lines of longitude? And we'll come back and talk about this next.